Module 10. Genetic Improvement Strategies and Sustainable Breeding Programs in Livestock. Module Overview. Module 10 focuses on strategic approaches to genetic improvement and the development of sustainable breeding programs for livestock. This module emphasizes long-term planning, selection methods, integration of advanced genetics, and the balancing of productivity with sustainability. You will explore comprehensive strategies for maximizing genetic gain, improving herd performance, and ensuring environmental and economic sustainability. The module integrates classical breeding principles with modern genomic technologies, providing you with advanced analytical frameworks and decision-making tools for designing and managing breeding programs across diverse livestock species. Special emphasis is placed on selection indices, crossbreeding strategies, genomic selection, and ethical considerations in sustainable livestock production. Key topics in genetic improvement and sustainable breeding principles of genetic improvement in livestock, concepts of heritability, genetic variation, and genetic correlations. Quantitative and qualitative traits and their relevance to selection. Estimation of breeding values and their role in selection programs. Identifying key traits for productivity, disease resistance, and adaptability. Selection methods. Phenotypic selection, choosing animals based on observable traits. Pedigree selection, evaluating family histories for trait inheritance. Progeny testing, measuring offspring performance to assess parental genetic merit. Advantages, limitations, and integration of multiple selection methods. Crossbreeding and hybrid vigor concepts of heterosis, hybrid vigor, and complementarity. Crossbreeding strategies to improve growth rate, fertility, and resilience. Breed combinations for specific production environments. Long-term genetic planning to maintain genetic diversity and avoid inbreeding depression. Genomic selection and marker-assisted breeding. Use of DNA markers, single nucleotide polymorphisms, and genomic information to predict breeding values. Integration of genomic selection with conventional methods for faster and more accurate genetic gain. Case studies: dairy cattle, beef cattle, sheep, goats, and pigs. Designing sustainable breeding programs, balancing productivity, genetic improvement, and environmental impact. Maintaining genetic diversity while selecting for desired traits. Economic and practical considerations for small-scale and commercial producers. Strategies for disease resistance, climate adaptation, and feed efficiency. Breeding program. Implementation and monitoring steps for planning, execution, and evaluation of breeding programs. Recording and data management. Pedigree, performance, and reproductive data. Adjustments based on program performance, market demands, and environmental changes. Use of software and decision support tools for genetic improvement monitoring. Ethical, legal, and social considerations. Animal welfare, public perception, and regulatory frameworks. Responsible use of reproductive technologies and genetic engineering. Balancing productivity with sustainability, community needs, and biodiversity conservation. Case studies and sustainable breeding examples of integrated breeding programs for dairy, beef, poultry, and small ruminants. Lessons learned in achieving genetic progress while maintaining long-term herd viability. Strategies for developing countries and resource-limited settings. Practical applications. Designing selection indices tailored to production goals. Implementing crossbreeding programs to exploit heterosis effectively. Utilizing genomic tools and marker-assisted selection for rapid genetic improvement. Creating sustainable breeding programs that consider productivity, welfare, and environmental impact. Monitoring herd performance and adjusting breeding strategies based on data-driven insights. Learning outcomes. By the end of Module 10, you will be able to design and implement effective genetic improvement strategies for livestock. Apply selection, crossbreeding, and genomic technologies to achieve breeding objectives. Balance productivity with sustainability in breeding programs. Monitor, evaluate, and refine breeding programs using performance and genetic data. Integrate ethical, environmental, and economic considerations into livestock genetic planning.